Hey everybody! Today we're talking about radical equations. And we're going to start off with a little example, which is, well, I wouldn't necessarily consider this a radical equation. It's an equation that has a radical number in it, but that's okay. So what if I've got x minus 4, there it is, equals the x times the square root of 3. There we go. No, not x, 3. Bam, there we go. So I wouldn't quite consider this a true radical equation. The radical equations in my mind have variables hiding underneath the radical, okay? This is like just a number. So, not quite. There we go. So, the square root of 3, or x times the square root of 3, I just want to point out, is the same as the square root of 3 times x. So the square root of 3 is just a coefficient. It's just some number in front of x. In fact, it's about 1.73, but that's not important. We're going to get an exact answer here. So if I want to solve this, I've got a 1x and a square roots of 3x. So I want to bring those together. Which one's the smaller one? 1x is, so I'll subtract x from both sides. And I'll have negative 4 equals, and square root of 3x minus 1x, you might be able to think of it like, well, I don't know what the square root of 3 minus 1 is, but I know that that would be the coefficient, right? So you could write it that way, which is actually not that bad. That would work out. Or maybe you just be like, I don't know how to combine those just yet. I'm just going to write that as x times the square root of 3 minus x. And I got to get x by itself, so you could actually steal the x out of this, so that way I only have... Yeah, that's how we're going to write it. Yeah. So x times what would equal the thing above it? I'm going to blow my nose. My boogers are recorded on the internet now. Excellent. Hey. It's okay. So, x times what is x squared to 3? That's the square root of 3x. Nope, just the square root of 3. And x times what is negative x? Minus 1. So, what is this? This is just some number. It's probably 0.73-ish, right? And it's being multiplied by x. So, how do I get rid of that when it's being multiplied by x? Divide by it. Because x times 1 would equal the negative, or x times negative 1 would equal the negative x. If this was an x, then x times x would have been x squared. So that's why it had to be the 1. So let's see. So these cancel out, right? And I'll get x equals, I'm going to do a flipperoo on us here. Yeah, you're all set. Just get the internet off the homework off the internet. You know what I'm saying. My homework invented the internet. And that's my answer, but wait a minute. Mathematicians wouldn't like that for an answer. Why?
Because there's a radical on the bottom.
A little bit, I suppose. I sounded like a cartoon character. So what do I multiply it by?
The square root of 3 plus 1.
Oh, the conjugate. I like it a lot. So let's do this, friends. X equals, I'll distribute the, right, because vinculums are grouping symbols. So I have to multiply both those by 4. So I'll have negative 4 square roots of 3. And negative 4 times 1 is negative 4. Over, and I'm using a pattern on the denominator.
So it will equal a squared minus
So squared minus 1 squared, right? Yep. The numerator I can't simplify. I'm just going to call that n for a minute. Root 3 squared is 3. 1 squared is 1. So n over 2. Oh, and it looks like I could actually reduce those by 2. So I'm going to write that as negative 4 roots of 3 over 2 minus 4 over 2. Or you could have actually been like, I'm going to cancel this, this, and this by 2 and then replace those with 2's.
Why are you doing that?
Yeah, where'd you get the 4 over?
Well, I'm actually
Because it's-
taking the numerator and just putting each part of it over the denominator. So that's a couple of different ways you can do that trick, of course. But oh, and then what cancels out here? 2 goes into 2 once and into 4 twice. 2 goes into 2 once and into 4 twice. And I'll end up with negative 2 roots of 3 minus 2. Voila.
X equals.
Yep. Two sneezes. And I don't have to write the ones in the denominator because dividing by 1 is that, right? So this problem had a radical in it, but it was kind of just like a number. So let's talk about for real radical equations. Let's do that. So let's solve this guy. Exemple, solve. What if I have the square root of x equals 7? How would I solve that for x? What could I do to both sides to get x by itself?
Squaring them.
Yeah, squaring them, right? And if this was a cubed root, I would cube both sides, right? If it was a 7th root, I would raise both sides as a 7th power, right? I'm just going to undo using the inverse operation of square rooting, right, is squaring. So I'll get x equals 7 squared is 49. Solved it, right? Bam, not bad. What if I had this one? I'm going to do like 3 quick ones, and then we'll do the 2 long ones here. What if I have the square root of 2x minus 1 equals 4? Oh, but yeah, I can't add 1 to both sides because it's currently, yeah, it's like under the authority of this radical. Okay, yeah, let's do it. So we'll have 2x minus 1 equals 8. What is right? Well, I don't know what you're talking about, guys. 16. The 4 squared is not 8. Yep. Hey, I'm on cold medication right now. And also, I can't blame that on the cold medication. That was just me making a math mistake. 17, and then what do I do? Yeah, so you guys got this. You're experts. You guys are experts. Am I right? Experts. All right, one more quick one. Ready? What if I've got the cubed root of x plus 1 equals 28? Oh, so cube both sides?
No, but you can minus 1 first, don't you?
That sounds like a much better idea because if I cube this, I'm going to have to know my way to expand the cube of a binomial. And that's a pattern we only talked about once ever. So yeah, let's just minus 1 from both sides. So the idea is, remember back in the day of solving absolute value equations when we would isolate the absolute value first before we broke it up? Same idea. Get the radical by itself before you start trying to, cube both sides or whatever. Oh, and then what do I do? Cube it. And actually, I made a tough problem for myself. I thought I made an easy one, but nope. My brain was thinking backwards. X is equal to whatever 27 cubed is. Yeah. Which is 19683. Actually, funny thing, I was born in 1983. 6 in the middle? I don't know, almost. What? I'm 30 years old! How old did you think I was?
Like 24.
Yeah.
Wow.
You don't look 30.
It's all my clean living because I don't do drugs, I don't drink,
Ew, no.
I don't
you
punch
definitely
goats.
Look 30. You look 30.
I don't think it's 30.
I feel like they just don't think.
I think I could look 30, yeah.
You look 30.
If you shave,
I don't like it.
If I shave, I look like a baby.
You do.
Alright, so guys, check this out. What if I want to solve this equation, the square root of 5x minus 6 equals x? What? Alright, yeah, the radical's by itself. Okay, so let's square both sides. That's the only way I can get rid of this radical, right? So 5x minus 6 equals x squared. And now I just want to point something out. You may not have solved a quadratic equation since the days of Math 1/Algebra 1. That may have been the case. And I know this is a quadratic equation because, one, it's a quadratic right here, and it's an equation, right? So to solve quadratic equations, we're actually going to spend a whole chapter kind of covering some different techniques. Quad, EQ, right? Here's a general approach that will work for, I think, most of the problems we end up doing in this chapter before we do our full in-depth study. So to solve quadratic equations, what you're going to do is set it equal to 0. All right, that'll be step uno. Step 2, land on your right foot, don't forget it. No, we're going to factor. And then step 3 is set each factor equal to 0 and solve.
I would just like to say I love your Z's.
Yeah, with a little slash
That's
through
what
them.
I do too.
The main reason I do that is sometimes my 2's look like Z's if I'm not trying very hard. And sometimes I actually have X, Y, Z, and then like a 2Z, and then it's like, that's not helpful. so I have to make it distinct. Yeah. Some people also put like zeros like that.
I was going to say my zeros, my O's.
Actually, this is a theta. That would be a 0. Theta, 0.
Theta.
It's a Greek letter. We'll use it for angles later on at the end of Math 4.
It's a Pokemon.
Oh, it was a Pokemon? Pokeball? I don't know. Okay. So let's try this technique. So step 1, I'm going to set this equal to 0. And I'm going to set it equal to 0, keeping the x squared part positive. So I'm going to subtract the 5x and add the 6. I'm going to, look at this, I'm double moving right here. Ready?
What do you think you're doing?
Oh,
And I'm going to flip-a-roo at the same time. X squared minus 5x plus 6 equals 0, right? Because I would have gotten 0 equals all of this stuff. And I was like, that's weird. I'm going to put that stuff on the left side. So that's what I did. All right, so I set it equal to 0. Check, right? Now, well, if I subtract 6, then it won't be equal to 0 anymore. What's my next step? Factor. If possible. These problems aren't technically always factorable, but I think the ones that you get on the homework in this section will be.
Oh!
Can I GCF?
No.
No. Is it a pattern?
Yes.
This is a perfect square, but that one's not. Do I have to AC method it?
No.
No, because A is equal to 1. So I can just find the factors of 6
2 and 3.
that add to be 5.
Negative 5.
So they're both gonna be negative.
So it'll be 2 and 3. And so I'll have an x with a 2, an x
Wow.
with a 3
Make sure
equals 0. And their signs are the same because they multiply to be positive, they add to be negative, so minus, minus. So step 2 is done. All right? Now before I do step 3, I want to justify it for you real quick. If I, don't write this down, if I said 3x equals 0, what would you say x is? 0, right? Because 3 times 0 is 0, okay? If I said I had pi times 0, oh, nope, sorry. What if I had pi times x equals 0? You can see what I was trying to do. You'd say x had to be 0, right? What if I had 10 to the 218 times x equals 0? What would you say?
0.
X is 0. What if I said a times b equals 0?
So all of that is just 0.
Well, this is
A or B
the one of them.
A or b equals 0. So if this, then a equals 0 or b equals 0.
Should we write that down?
Sure. This is the zero product property. The old ZPP, right? So if a times b equals 0, then a or b equals 0. Could be both of them too, technically.
Can you say that?
So it's not technically a NOR situation, or I actually don't know. I can't remember all my logic rules now. But yeah, it could be A, could be B, could be both. But that's what we got. So zero product property. So behold, what do I have here? I've got this times this equals 0. So what could you tell me? Either the first part's equal to 0, or the second part is equal to 0. Or both. Yeah, or both. So let's now solve both of these. Add 2, add 2, add 3, add 3. And I'll get x equals 2, x equals 3.
What's your answer, okay?
Yeah. Yeah, go. So that's how you can solve a quadratic. I knew this was a quadratic because I saw a squared term show up in it, and there was an equal sign, okay? And now technically I could even do a check. Is 5 times 2 is 10, minus 6 is 4, the square root of that is 4. No, the square root of 4 is 2, sorry, I don't know what I just said, which equals 2, okay. And let's check 3. 5 times 3 is 15, 15 minus 6 is 9, the square root of 9 is 3, which equals 3. So it actually would check out in both cases. There is the possibility of extraneous solutions in this section again, so sometimes doing a check might be important. Last example, and we're awesome. Here we go. Solve. Here we go. I wrote this problem myself earlier. During lunch maybe? No, before class? I don't remember. Sometime though. The square root of 3x plus 10, all under the radical, minus 2, better yet, plus 2. But it didn't matter. You didn't have to erase anything to write that. Equals x. So, I could square it.
Or subtract 2.
I'll bring the 2
Subtract
over.
2 first.
Sorry. I was thinking it was under the bracket.
You wouldn't actually be wrong for squaring it. You would just make a hard life for
Difficult.
yourself.
I know, I thought it was underneath the...
Yeah, and that's why be very careful with your radicals. Uh-oh.
Uh-oh, what are you doing?
Uh-oh. That was a fake sneeze. Darn it. Oh, baba. So then I get x minus 2. So now I've
Square it.
isolated the radical, so now we square it. And let's see, I'm going to simplify this left side, and I'd get, oh, that's easy, 3x plus 10 equals, oh, good catch! I'm so devious with these. Oftentimes, students will just be like, oh, x squared minus 4. But it's super illegal to do this.
So you have to write x minus 2 times x minus 2.
Yep, you could do that and foil it, or foiled it. Or you could have a pattern memorized. And I know some of you tonight on your homework are going to see this. You're going to be like, I know I can't distribute it, but it seems like it'd be less work if I do that and do it wrong than doing it the real way. So I'm just going to keep distributing it. Right? Come on. Like, seriously. Do it the right way tonight. Come on. So, A is x, B is 2. Let's plug it in. So I'll have x squared minus 2 times x times 2 plus 2 all squared. Sniffles. 3x plus 10 equals x squared minus 4x plus 4. Now, thoughts. What do you guys think?
Oh, now you can subtract 10.
Well, you can turn that right side
Into the
to the greatest common
two.
whatever. You know,
This is a pattern, but I don't actually want to factor it because then it would bring me back here.
I would bring the x and the 10 over.
Well,
I would
actually, no, I'll
subtract
bring-
10.
What type of equation is this? Now, before we start moving stuff around, it's a quadratic equation. So don't start moving stuff around yet because once I notice this is quadratic, it's changed my objective. I'm not trying yet to get x by itself. I'm trying to get everything away from one side. Okay? So it's this situation. It's quadratic, so I want to set it equal to 0.
So say move the 3x and the 10 over.
Yeah, and tell you what, let's move both of them at the same time. Double move. And flipperoo at the same time. X squared minus 7x minus 6 equals 0. Wait, don't tell me I did this wrong. No. X squared minus, wait, come on, wait, no. Did I? No, wait.
You did not do that wrong,
Can't simplify that further.
What if, guys, can I make one change that's actually going to be an easy change? It won't actually be that hard to do.
No.
Well, I'm going to do it. Because I want to make this problem friendly for us. I was wrong in my setup. Make this a minus sign. Minus, minus, minus.
We're gonna mess this up. Now you're gonna add it?
And then we're going to add it. Just so that way it's an easier problem for us to do. My bad. My bad, friends. And what's my middle term going to be now?
Minus
X.
Minus x. Okay. Whew. My apologies, friends.
Then we're gonna do factoring.
So now we factor it, exactly. Is this GCF?
No.
No. If it was, I should, though. Is this a pattern?
Yeah.
No.
Yeah.
Perfect square here, not there. So, is this an AC method problem?
No.
Nope, because A is
It's not
1. So find the factors of 6, 1 and 6, 2 and 3. Which of those subtract to be 1? 2 and 3?
No, why would it be 1 and 6? That's 2 and 3. Ugh.
X with a 2, X with a 3,
I just got very upset
No,
about
I'm just saying you
this.
guys pay attention, that's all.
Yeah.
and what are their signs?
The 2's positive, the 3's negative.
Yes.
I knew that the signs were different because they multiplied to be a negative 6.
Yeah.
And could someone explain why you knew the 3 was the negative one and not the 2?
Because it's a negative one.
Because it's more influential. The X is negative and it's
Because-
more influential.
No,
You
because-
guys got it.
Oh,
Yeah, because the negative x was, right, what results when I add those two things together, and therefore the more influential of them had to be negative. Right, perfect. So let's see, now I've factored this, what do I do now?
Split it up. Split it up. Split it up.
Set each factor equal to 0 using the zero product property. So either x plus 2 equals 0, or x minus 3 equals 0, or both. I like that you chime in on that each time. I like it.
I'm gonna. Every time.
Or both.
Okay. You don't say it or both every time, so I will.
Sure. So I'll get x equals -2 or x equals 3. 2 answers, friends. 2 answers. We did it. We did it. We did it.
Guys, we're not on Dora.
So
Stop it.
now technically I should be very careful and do a check of this. So remember that is a minus sign now, a -3x. So technically I should do a check, but I'm not gonna right now. So I think we're
That's
good.
right there. It's not going to do that.
So goodbye, internet friends. Thanks for watching.